word 1, word 2, word 3. With the note that this is very close to what you need for test 6 part 1. Be up to y'all. And then we return the result. So we must get reading. The reason we don't need to use string here is reading is already a string. And we can see the concatenated 1, 2, 3 here. With our 3 values of 1, 2, and 3. Again, it's not going to automatically add in any punctuation, grammar, spacing. You're going to have to do that manually. So combine what I have inside a sentence with here, and it'll get you on the right path. And we can see an example with hello world as well with the exclamation point. Now, we've talked about pretty much everything about methods. We've made int, double, and string methods. We could go through and make others. But what we haven't actually talked about and what we don't have in notes is going to be about each individual key piece. So the return type, the identifier, parameters. So I'm going to find where I put my notes section somewhere here. And we're going to talk about basically put all of that in notes. So when we write a method, like what we've done so far, what we've seen on the slides, it's going to have multiple parts for the signature or head of the method. The return type, the identifier, the parameter list. And then when we have a return that isn't void specifically, we must have a return line inside of the scope of the method that returns a value that shares a type with the return type of the method. So the identifier of a method is just going to be like the identifier of a variable. We can name it whatever we want, provided we follow the rules of making an identifier. Those rules, again, are going to be any character capital or lower a through capital or lower z, 0 through 9, and underscores. On the 0 through 9, any identifier cannot start with a numeric value. Also on this, we have different notations that we write things with, or utilize when we're writing our identifiers. The two that are used most often are called camel case and Pascal case. So camel case notation is the first character of the first word is lowercase, but any preceding first character of other words is capitalized. This is used for variables. It's a visual tool to help immediately identify what something is. And what I mean by that is the other type of notation is used for classes, methods, functions, and procedures called Pascal notation. All right, next bit is going to be parameter list. Every method we write will have a parameter list, at least the parentheses. We don't need to write any actual parameters unless we need to. It's going to be up to either instructions or what we think the method needs. But when we write a method, no matter what, the parentheses will be present. Expanded on that, parameters themselves. These are variables that we set up for use in the method. And they're utilized when we call. See the examples down below, where we have sum and its overloaded counterparts, and where we call sum in the main. Also, you can use message as an example. If a parameter exists when we call the method, we must provide a value of the same type as the parameter. Next is going to be scope. Every method will have scope, denoted with the curly braces, scope braces, whatever you want to call them. Generally, they do not have a semicolon at the end of them, so you won't be writing something like that for the time being. There are reasons for it later on, but we don't get into it because you want all of your methods scope will look like that. And then as pseudocode examples, and then just recreating some as an example to have pseudocode examples of a void method and a method with a return type. We can see that void, no return, but if it's something other than void, like int, string, bool, var, etc., there will be a return line. Do we have any questions on the structure of the method itself? Back up to the notes. Tell me when to stop. The other things to note about methods is we can have any code construct, pretty much any code construct inside of a method. They generally aren't used for single line things. However, expanded on that rather, single line thing being like where we have int sum and it's returning the value of the value effectively, where we just add it together and return the value. However, the reason we do that is it is much easier to read the word sum and have the immediate context of what's happening compared to looking at a screen full of equations and if they're not separated, depending on how easy it is for each individual to read a wall of text that has a bunch of equations on it. I typically will get a wall of text with equations. I try to space it out or have methods like sum or anything else to make it easier to read for me.
Is there a limit to the amount of strings you can cat together?
I'm sure there is eventually, but there would be no reason to, other than to test it, to test it. Because generally, I think the most that I've ever animated together is like 5 or 6, and it's from multiple different sources, like different objects, which is going to be from like day 7 and 8. But I don't think there's like a feasible cap that you can reach. So with the last bit of notes that I wrote in mine, where we can have pretty much any code construct inside of a method, they generally aren't used for single line things like our sum method, where it just adds the value and returns it. That, as an example, is an organizational tool that is perfectly fine to have. Like, we've obviously done it. And when we go down to our main, even though a lot of it is separated just from habit from being, and with the comments, where we could break all of these down into their individual equations, it'll be easy for me to read. However, if this entire page was no spacing and a bunch of equations, I'd get lost pretty quickly until I either added spaces or turned everything into its own method. Now, what I mean by having multiple code constructs in there, and we can see an example with Hello World as well with the exclamation point. Now, we've talked about pretty much everything about methods. We've made int, double, and string methods. We could go through and make others, but what we haven't actually talked about and what we don't have in notes is going to be about each individual key piece. So the return type, the identifier, parameters. So I'm going to find where I put my notes section somewhere here. And we're going to talk about, basically put all of that in notes. So when we write a method, like what we've done so far, and what we've seen on the slides, it's going to have multiple parts for the signature or head of the method. The return type, the identifier, the parameter list, and the string. And then when we have a return that isn't void specifically, we must have a return line. So notes that I wrote in mine where we can have pretty much any code construct inside of a method. They generally aren't used for single line things like our sum method, where it just adds the value and returns it. That, as an example, is an organizational tool that is perfectly fine to have. Like, we've obviously done it. And when we go down to our main, even though a lot of it is separated just from habit from being and with the comments, where we could break all of these down into their individual equations, it'll be easier for me to read. However, if this entire page was no spacing or a bunch of equations, I'd get lost pretty quickly until I either added spaces or turned everything into its own method. Now, what I mean by having multiple code constructs in there is what we can do is we're going to start with a void method. So above the main, I'm not sure what I want to call this yet, so I'm going to call it method. And I'm not sure if I want any parameters yet, so I'm going to leave the structure like that. So void method, no parameters so far. So far inside here, I have a cout to prompt the user for their favorite band or artist, and I have a string for user. Now, I don't believe I've used a send statement yet in this example. I'll scroll back down to the method here in a minute. The reason I am looking for a send statement is if you mix and match that with getLine, sometimes it causes issues, and I would prefer to use getLine here. So I have not used cn. So we're going to use getLine.
Can you refresh me on what getLine it does?
So getLine is a version of accepting user input, and the difference between getLine and cn is if we use cn, we can type in whatever we want without however many spaces as we want. But cn will only capture whatever set of characters is before the first space. So one of my favorite artists or bands is 9 Inch Nails. 3 words, not 1 word. If we use a cn statement by itself, it would only capture 9. If we use a getLine, it would capture the entire band name.
The entire line.
All right, so before we add anything else to this method, we're going to call it, and then we're going to run. So at the very bottom, because that's where we put the method call, or at least I did, at the bottom of our main, so it's going to be the last thing that runs. We get the prompt for what is your favorite band or artist. So in this case, and we can see that here. Now, if we wanted to see the example of what I described in the notes, what we'll do is we'll change that get line to a just a regular CN statement. So we'll comment this out. And do CN extract into user input. And we can see that it captures the first series of characters before the first space. There's use cases for both. If you're wanting something that has more than one word, you're obviously going to use getLine. But if you're looking for like one word answers, maybe you're asking like a yes or no question, or later on in like I believe day 5 or day 6, we do like a text-based menu. So if you think of like a video game, Doom is the first one that comes to mind, like old Doom or even new Doom, like 2016, I don't know what their date is. You're typically going to see like new game, load, options, exit, maybe some other stuff. We're going to do something similar but in a text-based fashion. And in that case, a lot of the time it's going to be like, if we use like the new game, load game, etc., we're only going to be looking for like 1 referring to new game, 2 referring to load game, 3 referring to options. So the user's going to type in like 1, 2, or 3. You're not going to type in like new game, load game, etc. So that could be a use case where you can send over getLine. And now we have a second prompt with a getLine and a CN statement. So in practice, what I have seen before, because we're utilizing a CN statement and a getLine statement, this will probably not run. That's just what I've seen in the past. So we can see that it did skip the getLine because we're utilizing a CN and a getLine. That's typically the issue that I run into when I see this. You're going to want to pick one or the other. So if you ever have input that's going to be more than one word, everything's going to be a getLine. If everything is going to be a singular thing, send statement. Just to double check that it actually works. Now let's type in both. going to do much more for this method itself after that, besides adding in the user input into the string. So we're effectively building a string out of the user prompts. So we ask them one time what is their favorite band or artist. We accept it, we output it. And we can say band list plus equals input. The variable, not the string, literals, no quotes. This concatenates the user input into the band list variable. You've probably seen these in lecture 1 or lecture 2. There's one for each mathematical operator. There's a minus equal, a times equal, a divide equal, and a modulo. That is the shorthand version of this. You may have seen an example of this in day 1 or day 2, but you probably have not seen an example of this specific concept in real world math. In programming, we have one way to kind of understand it is this is the new value of band list equals the old value of band list plus whatever you're adding to it. So the new version of the variable is equaling the old reference of the variable plus whatever we're adding to it. Now, if we wanted to also add in a space, we could say band list plus equal the space. And we can do the same thing down here. Now we built this string. So what I'm going to do is I'm going to change the type from void to string. And we're going to end up returning bandits. Now down here in our method, we've altered the structure of it, but we haven't altered any parameters, so we're not going to get an error here. Now if I run this, which is something that I haven't described this entire time, but I haven't. We'll go into that here in a minute. But I rebuild this and run this, we're not going to see that band list run because we're not outputting that variable specifically. We'll get the output that we did, but when we run a method that doesn't have, or that has a return in it, and we're not storing or utilizing that return value, it gets quote unquote destroyed. It may still be there in memory. That's something to look up for later. I haven't done the research myself to bother looking for it. What's important though is we have no way to retrieve that value after it runs. So we're returning band list, which is effectively going to be the concatenated strings of the user input. But unless we do something like greeting equals sentence, where 1, 2, and 3 get concatenated together, sentence returns a string, so we can peek the definition of it. We can see that result equals word 1 plus word 2 plus word 3, returning result. We're storing that inside of greeting. Same thing with the sums. So if I scroll up to any version of sum, we're going to have captured return equals sum, holds double return equals the return value of sum. You don't always need to store it inside of a variable if you don't need to. What you could do if you want to just strictly output it and not store it for whatever reason, you can do the method call inside of CF statement. So now if I rebuild this and run it, output. Okay, I know why that's happening. So the reason why we're getting that specific output for user input is this specifically, what I'm about to highlight, is inside of the method itself. And it's not adding a new line because somewhere in that method, I did not place an ML. Right here. So that output from that cout is this final line. If we wanted to confirm that, we could just insert something else into the IO stream or concatenate something else. And we get that altered output because we inserted a string literal for formatting, and we can confirm that we're getting those two things from the method. Now, if we wanted to store it, and output it with message, we can do that as well. And we get the message file formatted with 2 lines and then the built string from our method. Now, before we go on another break, do we have any questions on anything we've seen so far? If no questions, we're going to take another time. Go ahead and be back at 3:36. I'm going to pause the recording. All right. For the remainder of our time, we're going to do a little bit of review on just day 1 and day 2 material. We've pretty much done everything we need to do for day 3 stuff, unless you might have a specific example we want to see, or any questions that we might have on methods themselves. So what I'm going to do is I'm going to create a method void day 1 and void day 2. Starting with day 1. Just for notes and structure, we have input, output, catenation, types, assignment, and operators. So for input output, we've seen it basically all 3 days. We have cin, get line, cout, cin, console input, cout, console output. Operators that we've seen so far up until today.
Plus, minus, division, multiplication, module, exclamation point.
Along with the insertion, extraction, and scope resolution. So, just a quick rundown. All right, so for the operators, we have typical arithmetic operators. The addition sign also being part of concatenation. Something that you might have messed with already. You've 100% seen it in the slides. I just can't remember if you've actually used it yet. Is the percent sign, which is mod, modulus, or modulo, basically the same thing. It is division, but only for the remainder, where the actual division sign is for the quotient or the result of that division. So if you did like 10 divided by 3 with the slash, you'd get 3. If you did 10 mod 3, you'd get 1. Down here is shorthand common operators. I'm sorry, that is a note. And what I'll do here is end of that note, begin another. You can see examples of the operators themselves. So simple addition there, where we have z equals 3 plus 3. If we output z and then the actual variable z, we'd get 6. But if we did z equals z plus x. Z is now 9. And for the actual shorthand, we can do z plus equal any value we want. So we'll use y in this case, so z will now be 11. So we haven't done quite a lot inside of the day one method. Just a bunch of notes and 3 outputs and some variable declaration. However, if we wanted to see all of that, we would have to call that method. So simple addition there, where we have z equals 3 plus 3. If we output z and then the actual variable z, we'd get 6. But if we did z equals z plus x, z is now 9. And for the actual shorthand, we can do z plus equal any value we want. So we'll use y in this case, so z will now be 11. So we haven't done quite a lot inside of the day one method. Just a bunch of notes and 3 outputs and some variable declaration. However, if we wanted to see all of that, we would have to call So we haven't done quite a lot inside of the day one method. Just a bunch of notes and 3 outputs and some variable declaration. However, if we wanted to see all of that, we would have to call that method. So this is when the output starts getting a little bit longer. We're going to have a bunch of input and output. And what we're actually looking at right now is the bottom 3 lines that come from day one. The values are z. So we can see the shorthand way, the longhand way, with z equals z plus x or z plus equal y. Also, notes on the insertion operator, extraction operator, scope resolution. Insertion, typically what you're going to see in this course is just inserting the CI statements. So any of the live demos that Doug or I do, and then you'll utilize them in the midterm and final. Extraction used for CN statements, typically to extract something from the IO stream. So in this case for the course, the IO stream specifically referring to COut or CN. Scope resolution gets talked about a little bit. We talk about it in day one. So you're pretty used to seeing like SCD : Cout. That's the standard library with the scope resolution next to some entity. So you're going to see like that very often on COut, CN, stream, and various other things that come from specific libraries that are not native network. So imagine if all of us wrote a library and we rewrote how COut or CN or anything else worked. The reason we type in the standard library with scope resolution is we are calling COut from that library. If we wanted to call from the library that we specifically made, say we call that library A, we would say A scope resolution, COut. And it would differentiate between the different versions of that construct. You'll see a lot of that later on, but because we don't utilize namespace anymore, something you'll learn about later, probably if you need to, we have to utilize the scope resolution fairly often. Next is going to be concatenation, or the chaining of strings, or adding of strings. So with that note in mind, we're going to end that note, start another. And what I mean by chaining of strings, adding of strings, but we can only utilize one string literal, is strings with me. That's an answer. what we're actually looking at right now is the bottom three lines that come from day one. The values are z. So we can see the shorthand way, the longhand way, where z equals z plus x or z plus equal y. Also, notes on the insertion operator, extraction operator, scope resolution. Insertion, typically what you're going to see in this course is just inserting the CI statements. So any of the live demos that Doug or I do, and then you'll utilize them in the midterm and final. Extraction used for CN statements, typically to extract something from the IO stream. So in this case for the course, the IO stream specifically referring to COut or CN. Scope resolution gets talked about a little bit. We talk about it in day one. So you're pretty used to seeing like std : cout. That's the standard library with the scope resolution next to some entity. So you're going to see like that very often on cout, cn, string, and various other things that come from specific libraries that are not native. So imagine if all of us wrote a library and we rewrote how cout or cn or anything else worked. The reason we type in the standard library with scope resolution is we are calling cout from that library. If we wanted to call from the library that we specifically made, say we call that library A, we would say A scope resolution cout. And it would differentiate between the different versions of that construct. You'll see a lot of that later on, but because we don't utilize namespace anymore, something you'll learn about later, probably in E2, we have to utilize the scope resolution as well. Next is going to be concatenation, or the chaining of strings, or adding of strings. So with that note in mind, we're going to end that note, start another. And what I mean by chaining of strings, adding of strings, but we can only utilize one string literal, is in other languages, this line would be perfectly fine. It's fairly redundant because it's 3 string literals, so 3 things that we type, dictate, whatever. We have hello, a space, and world. C++ sees this as redundant effectively and will force us to have it just as 1 string literal, like so. Now if I also try to do another string literal here, so we have hello space world, we're going to get effectively the same error, as we are working with 2 string literals. You may have seen an example of this in day one, but you probably have not seen an example of this specific concept in real. With me, say we call that library A, we would say A. And what I mean by chaining strings, adding strings, but we can only utilize one string literal, is in other languages, this line would be perfectly fine. It's fairly redundant because it's 3 string literals, so 3 things that we type, dictate, whatever. We have hello, a space, and world. C++ sees this as redundant effectively and will force us to have it just as 1 string literal, like so. Now if I also try to do another string literal here, so we have hello space world, we're going to get effectively the same error, as we are working with 2 string literals. So we can see no errors here, and if we were to see out this, it would work perfectly. We could see the word hello and then followed by space world. And from a question, I think towards the end of the break, how many concatenations can we have total? I'm going to create a bunch of variables. I'm going to give them values that don't really matter. We have one with a space and the rest of them don't have anything, but we are concatenating a bunch of different variables. If I were to Google this real quick, to actually see if there is a cap,
What you're showing there is what you would define up in your method, right? And then you would call that method and it would produce that.
so all of this is inside of the one method. And we call it down below inside of main. So effectively, you can have any code inside of a method and then called method, or like at least with the live demos, because the labs are structured differently. We can have all of this in the main. The reason we separated it is A, showing another method. B, if we don't want to see this during the execution of the project. So granted, right now, I think there's only 3 output lines inside of day 1. Yeah, right here. So if I were to run it right now, at the very bottom, we get the 3 outputs for Z. If we didn't want to see all of the outputs for day 1, we could just comment on that. No, we don't have the outputs for the variable Z. And then the answer that I got from Google about concatenation and the amount of. So depending on your system, is going to dictate the amount of strings that you can realistically concatenate. And the size of the strings are going to be based on the value of them, because they are I can't think of the actual terminology, but we can think of it as a fluctuating type. In lecture 1, I believe, there's a series of slides that go through and show the size of each type, like N is 4, sheets are 2, cars I think are 1, floats or doubles are 8. I can't remember off the top of my head. I'd have to actually look at the chart. But when it comes to strings, like you can have a string that's like several paragraphs long or one character. The size is going to vary. However, because characters are very small, you could probably have several novels worth of characters inside of a string or multiple strings. And your system probably would not care, because nowadays the amount of RAM in a machine, RAM being random access memories, where it effectively gets stored without being permanently, quote unquote, saved to your machine, it's high. It's a high amount of memory effectively. So I would wager that it would probably be like a number higher than a minimum until your machine starts slowing down for your concatenation. But ultimately, you don't need to ever go that high with the number of variables that you're working with. You'd be probably writing on a bunch of variables. All right. With that, there's actually a question I don't get off. So a question from online. When should I use a colon versus a semicolon? So the only thing that I can think of off the top of my head from day 1 to 3 that utilizes a colon specifically is going to be an access model. I could be wrong on that, but that's currently the only thing that comes to mind. When we talk about a semicolon, this is the end of an executable line. Another way of thinking of this is a period is the end of a sentence. A semicolon is the end of a line of code. However, not every line of code knows a semicolon. Methods don't, and other constructs in day 4 and beyond do not as well. If you're missing a semicolon, the compiler will definitely throw an error. Sometimes when you're writing the code, but all the time when you go to build, rebuild, or run the local Windows debugger.
I noticed on your strings there, you have a space between number 1 on the double quotes. Does it matter whether there's a space or not?
That's a character.
Ultimately, no. So if
An empty.
I were to output this, and let's see, give to the
This is where the teaching part, when I was bitching and complaining about them not really teaching, this is where it comes in. The space is actually an empty space. And in their own notes, they tell us that if you have a semicolon with a space, the actual space itself is considered a character. It's a char. It's a char. So like how 2 is a char, nothing is a char. The two parentheses, I mean the 2 semicolon, I mean the 2 quotations next to each other, that is actually the way I would explain it, because I'm eccentric in the way I think, I would explain it as a void. It's a string that has no value. It would be a void. It would be a void string. That's how I would describe it. When you put a space in there, you give that string an actual value of a character, which is a space.
value of 2, because we won't see anything on the value, is that quite literally adds a space to the output. I think I commented out there. So we're going to uncomment that out, and then rerun this. Did I output anything up there? So actually outputting it so we can see it. So 1 having a space value, 2 having a 2. We're going to see hello world space 2 here. If I got rid of that space, rebuild and run, it's whether or not you.
And this is a perfect illustration of why it's hard to learn how to program. Hello world space 2 was the output because the compiler did something, right? He eliminated the space in the semicolons, but the example down here, hello is hello, world is, I think it's, which one is it? But each one of these, hello world space 2, they're all, so I'm gonna explain it. I'm just gonna explain it. I don't really have time to be doing YouTube stuff, so I'm just gonna explain it. It's gonna be mostly wrong, but I'm just gonna explain it anyway. Hello world, hello space world 2, and then in between world and 2, that 1 value, that 1 string is still outputted. The compiler still outputted that string 1 right there in between those 2. If you don't know anything about programming, you wouldn't notice. You wouldn't notice. He got rid of the space in between the 2 quotations here, but the compiler still ran std string 1 equals whatever. So if this semicolon was missing from this value right here, even though the space is gone, it would have did a runtime error, because even though you're trying to get rid of that value in the output, the computer still recognizes and acknowledges that it needs to draw nothing there. It still executed that command. So the command is, once you write the command into the actual compiler, the compiler has to do the work. So it still outputs nothing in that location. So it literally outputs no information there. It takes the time to say there is no information to put here, put that here. And it says 2 is next, and it puts 2 there.
To care to have any value in there, and if you want a space to be there. So in this case, if I were to actually provide values for 1, 2, 3, and 4 to show actual values for the concatenation, we probably do want some form of spacing in there, but ultimately it's going to be up to you and whatever you want to do to test out. Because that's what these live demos are there for, basically. If you're coding along, you're going to have it as you've written it. It might not be exactly like mine, but you'll be able to mess around with it, try and break it, add stuff to it. Or you can download mine, try and make yours similar to mine, or try and break mine down with it, add stuff, subtract stuff. It's all there for you to mess around with and try and get more practice with. So effectively what this is. So ultimately the values don't matter. It's going to be up to you and whatever you want.
Excuse me.
Get my whole number in there as well. We have the types that we've probably seen up until this point. There are others that we'll learn about in day 6 and beyond. There's also the other versions of them, so the unsigned versions, so like short and long. I think double and float also have unsigned versions. And then a note, basically, because I never remember the value ranges of these, but also a good thing to show is how I actually Google for things that I don't know. So to get the answer for string concatenation or anything in general, what I like to do is I'll go to Google or whatever search engine of choice you use. I'll start with the language, and then I'll type in a question or whatever I'm looking for. So if I wanted to see an example of cout, I would use C++ to cout. However, because I'm currently typing out the notes for data types, we can see data type, value ranges. Google is going to give, it's, I think Bard AI output. Most of the time this is okay. It's not okay all the time. Sometimes it gives really bad examples. So if you've looked at the research assignments in week 1, you're going to see videos from like Doug and some of the other instructors, along with a bunch of external links to resources that we think are easier to follow than official documentation. Doug may have talked about this already, where if we go to like Microsoft Learn, which is the official documentation for like C++, or I'm sorry, C#, and it has documentation for other types. The documentation can often include things that are not included in the course, and can be like a wall of text that's written in legalese, or not really legalese, but in legalese type of way. This one is kind of easy to follow. It's the chart that I'm basically looking for and a couple examples. So this one is perfectly fine. However, if you go and like look at other Microsoft documentation for other things, it could be a little intimidating. There are websites that I will typically point people and are in the references. The first one is going to be Geeks for Geeks. I can actually click it. There we go. Usually going to be a couple paragraphs, some examples of like actual code. Might sometimes include stuff that's not available for use in the class. That's going to be up for you to be able to recognize. So If you see something that looks like something Doug or I have not talked about, don't use it. However, you can quote unquote use it to gain understanding. You just cannot use the thing as part of your lab scenario plan. So here we have the same chart. So if you wanted to know the actual value ranges for the different types, this is where you could find it. You could also look at the Microsoft Google Docs as well. And then we can see some actual examples down below as well. Other resource that I would point people to Sephoro's Point, same type of deal. It's structured pretty much the same way. A couple paragraphs, the charts that we're looking for, that's the value ranges and the size of the actual types, and some examples down below. It's going to go into a pretty good depth of explanation, and it's formatted in a way, at least for me, that it's easier to understand. When I go and I look for things in different languages, I typically will look at Geeks for Geeks or Tutorials Point. The other one that I'll use if I want like the simplest explanation on something is going to be W3 Schools. So W3 Schools is going to give you like all the different types, the basic data types. It's probably like this one doesn't give us the exact range of values, but it gives us like shorthand versions of it. So like if we look at a float, it's sufficient for storing 6 to 7 decimal digits. If we look at a double, storing up to 15. It doesn't give us the actual value range. Also, unlike other websites, you can try it for yourself. So if you don't feel like opening up Visual Studio, we're going to have their own online compiler where we can test code. We can write down in here, change it around. And run it if we want. I do this all the time because once you start getting used to programming, you're not learning syntax. You may be learning syntax, you might be memorizing it, but ultimately when you get out into the workforce or you progress through your Fullsail career, you're going to be touching many, many languages. So I use Google like this every day. So we teach C++ in here. One of my projects that I do outside of Fullsail uses Python, and I am very used to working in C# or web languages like PHP. All of them written 100% differently. The ideas there are the same, so like all of them have some version of cout, all of them have these types in some form or fashion, Python being the exception. So Googling is going to be your best friend. And that is how, just as an example, how I would step up for that. For the rest of day one, I think we've done pretty much everything inside of day one. We are pretty short on time. Does anyone have any questions on anything up until the end of today? So day one material, day two material, day three material. Mm-hmm. Let me pull it up because I don't have it. You said 7, right? All right. So I pasted in the instructions for challenge 7 into the notes, but they're better formatted on it, so if everyone wants to look at them and want to. Print out a table of ranges for each of the system provided integral variable types, signed and unsigned. You may use the link provided to make it easier. There's a link to the Geeks for Geeks types in the tables. Point of this program is to introduce you to the fact that different variable types consume different amount of memory. The numbers themselves may seem arbitrary now, but when you learn how much each variable type consumes, you'll understand why those numbers are what they are. Resource, the link to Geeks to Geeks, and okay. Basically, the challenge is for you to actually like examine the table and just output all of the things. You're not computing anything, you're not equating anything, you're just outputting the type, if it's signed or unsigned, and the value range. That's all that challenge is. Yep. For D2, you start the debugging your conversions conversation. Okay, so there's a question about Lab 2. Lab 2 is the only lab that has multiple projects in it, and you can tackle it in any way that you want. So let me grab a fresh copy of that real quick. And we can look at that and also go over the output of the labs themselves. So when you grab Lab 2, you're actually getting two projects themselves. You're going to get conversions and debugging. If you go quote-unquote sequential in order, test 1 and test 2 are going to be in debugging. And debugging itself is two other things. So there's the actual C# or C++ project for debugging, and there's also the questions document that you're going to have to fill out after fixing all the errors inside of the debugging assignment. Then there's conversions, which are tests 3 through 10, I believe. So if we get this open, now we can see test 3 scroll all the way down to test 10. So like I said, Lab 2 is the only time that a project is broken out into multiple projects. You can tackle them in any order that you want. You don't have to start with debugging. You don't have to start with conversions. You can do either of them. But also, while I have this lab open, we can run it. And even though everything is going to fail, we can look at the output and see how it can help us debug our code to try and get the answer. Lab 2 through 8 will have the exact same structure as what we're seeing on screen right now. There is going to be a section of output for each test. Each test is attempted 5 times automatically by code we have in the background. So that's what the pass 1 of 5, 2 of 5, 3 of 5 mean. The next column is going to be a pass-fail. So if it's red, it's going to say fail. If it's green, it's going to say pass. For you to receive credit for the test itself, all of them have to pass. So you may see points like 0 out of 10 or 2 out of 10, 4 out of 10, etc. It has to have all 5 passes to get credit for that specific test. Next, because I know this is a thing every month, we're looking at this column right here, input, and these values. So we're specifically looking at test 3, but this is going to be true for every test method for labs 2 through 8. I scroll down to test 3 in the code, and we can see our parameter string input. Now, based on the lecture today, where we wrote,
I think he's going to say we need to return the string.
a bunch of parameters, when we actually made those parameters, we didn't assign them values. When we call the method is when we pass values into the parameter. When you're doing your labs, you're getting randomly generated values for those parameters. So looking at 2, 3, and -3 right here, if I close this, I guarantee you it's not going to be 2, 3, and -3. It very well could be like 1 in a million chance, but we have 5, 9, and -5. So the parameters right here are going to have values at runtime. The next is going to be the expected output. Effectively, the answer we're looking for with that randomly generated value in mind. So lab 2 specifically is all about converting values from strings to a specified target type. So test 3 is from a string to an integer, test 4 is from a string to a double, so on and so forth. You're going to see that the input mostly matches the expected output. It's just going to be missing strings for most of these, because most of them are a string to a target type, where only like a few of them are from a string to, or from a numeric type to a string. So right here, test 8 being that example. The received output is going to be what you put as your answer. So all of them with a blank lab, freshly downloaded, mostly going to be 0 or like empty strings or the word null. You heard me use the phrase earlier when I was explaining returns as for the purpose of this course. One of the ways that we can think of a return for our lab specifically is where we would put our answer. So if I were to change this return to be 4, and before I rerun it, received output is 0, I rerun it, it's now all 4. Do you have any questions on how to examine the output of any of our labs? Because all of them are structured the same way.
On specifically 3, are we doing C out or CN on any of these?
The labs themselves, labs 2 through 8 specifically, do not utilize CR or CN. Lab 1 does. The midterm and final do as well. So you don't have to worry about outputting anything or providing values. We provide the values and do the output.
And that's the reason why it's so fucking complicated. They should have us build, our first week we should build our labs. And that way we would understand the lab, so that when we start using a lab, it would be more intuitive. But since you just give us a lab and you have no experience in programming, it's super confusing. It's probably reasonable within the scope of what they're trying to achieve, but it's super confusing for someone that doesn't have any experience in programming.
So the last question, so we're making strings for the values provided? Not necessarily so. So like if we look at test 3 right here, we give you this parameter string input. If I run this one more time, we can see that input has a value of 9 on the first attempt, it has a value of 8 on the second attempt, 0 on the third, etc. So you don't ever have to make values for the parameters. They are randomly generated for you and given to you. If there are no other questions, at least for the time being, campus, feel free to take a break. I believe your lab is going to be in this room at 5:30. That's typically what it is every month. If it isn't, just obviously correct yourself. go to the proper spot. For online students, I will keep Zoom going for 5-ish minutes. If there's any other questions, I'll get them answered, and then after that, I will Zoom and get the project uploaded into the teacher learner.